LEDs, which in full means light emitting diodes, means they emit light or photons. You have them used in different ways: the LED matrix cube, shops display, or any other things you have seen them used for. But how do you determine the right resistor for an LED, either in series or parallel? What we need for this video are few LEDs, 9V battery, and some few resistors. So you should be following everything in this video to get more understanding. I do have a red LED on my breadboard, but we need a resistor here to limit inrush current from destroying our LED. But how do we determine the right resistor for this LED? So we will apply the Ohm's law triangle. But before we do that, we need to check for LED forward voltage drop and current rating. Looking from the datasheet, we find each LED voltage drop, and the red has a voltage drop rated 2 volts. We can see from the data chart that at 2 volts, 20 milliamp current should flow, but if apply 1.6 volt, we should have 0 milliamp of current. So the LED remains off. From Ohm's law, to find resistance, we have to divide the voltage by its current. So to do that, we first subtract voltage drop of LED 2 volt from the 9 volt power supply, which gives 7 volt. So 7 volt divided 20 milliamp gives 350 ohms resistor. But wait, how did I get 0.02 amps? Because if you type in 7 volts divided by 20 on your calculator is going to calculate 20 in amps. So we convert 20 milliamps to amps, and 1 amps equals 1000 milliamps. So we then divide 20 milliamps by 1000 and we get 0.02 amps. I don't have 350 ohms resistor, but I do have 390 ohms. But mind you, it should not exceed more than 21 milliamps, but falls below this number because this determines the lifespan of our LED. So from Ohm's triangle, we need to determine our current. 7 volt divided 390 ohms is 18 milliamps. So that's still okay for our LED. To calculate how long will this battery power our circuit, we divide the battery capacity by its circuit current. That's 500 milliamp divided by 80 milliamps. Remember to convert these to amp before dividing them when using your calculator, and we get 27 hours. So our battery should power our circuit for 27 hours. But the sad reality is that this doesn't really happen because of the internal resistance of a battery or any cell. So now you can now see our LED illuminating in a perfect condition with the 390 ohms resistor. If I swap the LED in reverse, you see it doesn't light up. If we look from this transparent type, we have the shorter lead, which is the cathode, and its lead frame called the anvil, and the longer lead is the anode, and its lead frame is the post. If we pass current in forward direction, this flows into the LED and turn on our LED. But if we reverse the polarity, the current gets blocked at this point and can't go any further. Also check for our voltage drop of our LED. Here we do see around 1.8 volts, and at the battery we have 8.4 volts. That's because my battery has already been in use, but that's fine. And for our current, we have 16.9 milliamps, but that's still close to our calculation. Remember, sometimes our meter aren't that accurate like mine. Here we do have a green LED, but it's not bright enough. It's because it's not the right resistor for this LED. Okay, do find this before I do, and leave your answers on the comment section below. From its details, we have that the voltage drop is around 4 volts. 9 volt subtract 4 volts and we are left with 5 volts. So 5 volt divided by 20 milliamps of current, we are left with 250 ohms. So we need a 250 ohms resistor. And we can see now that our LED is now brighter. We can connect LEDs in parallel in two ways. We can have them share the same resistor as long as they are identical, or have each of them connected to a resistor. Well, this method will be fine if they have different colors, and to do each calculation for each of those LED. And we can connect them in series, but in series their voltage drops all adds up together, and from our calculation we have 50 ohms of resistor needed. Alright, that's all for this video. If this video was helpful, please do leave a comment and share this video with your friends, and don't forget to subscribe. Okay, check out for this video how to design LED with the CD4017 and other videos using the link below the description box. So stay creative, and I will see you next time.